Hello everyone and welcome back to ImTechnos. In today's video, we are diving into IAM users, an essential part of AWS identity and access management. Let's begin by understanding what an IAM user is. An IAM user is essentially a digital identity or entity that you create within your AWS account. It represents a person or application that interacts with AWS services. Now let's see how to create an IAM user. I'm in the AWS Management Console. Presently, I'm logged into the root account. For those who don't know what a root account is, it is the original account that gets created when you first sign up for AWS. It has unrestricted access to all resources and settings in the AWS account. So it's recommended to use it only for essential tasks and to secure it with multi-factor authentication. For more information, I have already made a video explaining what a root account is and how IAM identities access AWS services. I have included the video link in the description below, so please check it out. In the search bar at the top, type IAM and select it from the drop-down options. You will then be directed to the IAM dashboard. In the left-hand navigation pane, select Users under Access Management and you will see a list of existing users, if any. To create a new user, click on a Create User at the top right corner. In the username field, enter a name for the user, for example, test user. For programmatic access, the access keys will be created after the IAM user is created. For now, I'll enable provide user access to the AWS Management Console, and under user type, I'll choose IAM user. You can allow AWS to generate a password for the user, or you can set a custom password. You can also enable the option for users to create a new password at their next sign-in. However, I will keep this option disabled and click Next. You have three options under Set Permissions. Add user to group. Add a user to an existing group that already has permissions. And copy permissions. So you can clone permissions from another IAM user. And the third one is attach policies directly. Choose built-in policies like Amazon S3 read-only policy or EC2 full access policy. Choose the option that best fits your needs. In this case, I will select attach policies directly, search for EC2 full access, enable it, and then click Next. Under Review and Create, review all the details on the summary page. Optionally, you can add key value tags to organize users. For example, you can keep a key as department and value as DevOps. If everything looks good, click Create User. Once the user is created, you will see details such as console, sign-in URL, username, and password. You can download, copy, or email these credentials for future logins. Now open a private window to avoid interference with my current session. I'll paste the URL and you will see my account ID is already populated. So provide the IAM username and password and then click Sign In. You will be directed to the AWS console homepage. At the top right corner, you will see the username along with the root account ID. And this user has EC2 full access policy attached, which means they have full permissions to work with EC2 service. For example, launching an EC2 instance. First, go to North Virginia region. While the user can launch instance in any region, I am choosing North Virginia for this demonstration. In the search bar, type EC2 and navigate to the EC2 dashboard. In the left-hand navigation pane, click Instances and click on Launch Instances. Name the instance as Console Instance. Proceed without a key pair. and click Launch Instance. So as we are only testing the user's access, I'm choosing the minimum required options to launch the instance. Now go to View All Instances and refresh the page. You will see the instance is now reflecting in the list. This demonstrates the importance of IAM policies. They define what an IAM user is allowed to do in your AWS account. Now go back to the root account, click Return to Users List, make sure you save the credentials and click Continue. Then click on the username. Under Summary section, you will see ARN. ARN stands for Amazon Resource Name, and it is the unique identifier assigned to every AWS resource. In the case of an IAM user, the ARN helps in identifying that specific user across all AWS services. And it is often used in policies to define permissions for that particular user. You will also see the creation date and time. This user have access to AWS Management Console. However, MFA is not enabled. So MFA stands for multi-factor authentication. It is an additional layer of security on top of your credentials. I'll show you how to enable MFA in a future video. And you will also see the last console sign-in column, which shows when the user last signed in to AWS through the console. You will use this information to identify users with passwords who have not signed in for a specific period of time. The column displays never for users with passwords that have never been used to sign in. If it displays none, that indicates users with no passwords. Now, passwords that have not been used recently might be good candidates for removal. And this column helps track a user's recent activity and is useful for security audits. Now, if you scroll down, you will see permission section. It displays that policies that are currently attached to the user. You can add more policies by clicking on Add Permissions. Here, choose Attach Policies directly. Search for relevant policies. For example, S3 full access policy. Enable it. Review the selection and click Add Permissions. You will now see Amazon S3 full access policy is listed under the permissions. If you have added a policy by mistake, you can simply select the policy and click Remove and confirm the removal. And under Add Permissions, you will also see Create Inline Policy. See, the policies that are here are the managed policies. These are predefined rules that allow access to AWS services which can be applied to multiple users at the same time. They can be created and managed either by AWS or by you, means the customer. But an inline policy is used when you want to create a policy that is specifically and exclusively attached to a single user. So unlike managed policies, inline policy stays inside the user and cannot be shared or used by other users. And they are useful when you want to give a unique set of permissions only to that particular user. So after clicking Create Inline Policy, you will be directed to the Create Policy screen where you can define the permissions. So in the visual editor, you can choose permissions you want to grant the user. For example, you can choose permissions related to services like S3, EC2, IAM, and other services. Alternatively, you can use JSON editor if you want to manually write the policy in JSON format. Here, I am pasting an inline policy that provides EC2 instance launch permissions. After that, click Next. On the Review and Create page, you will need to provide a policy name. And this name should clearly describe the policy's purpose. For example, you can name it as Allow EC2 instance launch. Once the policy details are reviewed and confirmed, click on Create Policy. The inline policy will now be attached to the selected IAM user. And you can see this policy under the permissions tab for that user. Okay. Now under the groups tab, you will see if the user is added into any user group. So user groups are a collection of IAM users. They are used to assign the same set of permissions to multiple users at once, making it easier to manage permissions consistently across your organization. And then the tags tab, it is used to add metadata to the user in the form of key value pairs. And tags help you organize, identify, and manage users more effectively, especially in large environments. Okay, for example, you can add tag users based on a department, project, or role. The Security Credentials tab provides access to manage credentials for the IAM user. This includes the password for AWS Management Console, the multi-factor authentication settings, access keys for programmatic access via CLI, SDK, or APIs, SSH public keys for AWS code commit, and other security-related credentials. Let's say I wanted to remove console access for the user. So click on Manage Console Access, then choose Disable Access. Once disabled, the user will no longer be able to log in into the console. If you later decide to restore console access, click Enable Console Access, set a new password, and click on Enable Console Access. So don't forget to download the credentials and share them with the user later. Similarly, you can enable or rotate credentials, deactivate or delete them, and enhance account security by following IAM best practices. And finally, the last access tab. This tab provides information on when and where the IAM user last accessed various AWS services. It helps you monitor activity, understand usage patterns, and improve security by identifying unused permissions or accounts. Now, the option which I intentionally missed initially under the summary is access key. This access key allows the IAM user to access AWS services programmatically using the AWS CLI, SDKs, or APIs. It consists of an access key ID and a secret access key. And these keys should be kept secure as they provide the same level of access as the user's permissions allow. So let me click on Create Access Key, and you will see a few options for what you want to create the key for, such as the command line interface, the SDKs, or other development tools. Choose the most appropriate use case. I am choosing CLI. Confirm the option and click Next. You can add a description tag if needed. I'll give a description like CLI access. And then click Create Access Key. Once the access key is generated, make sure to download or copy the access key and secret access key immediately, as you won't be able to view the secret access key again after this step. Now open your terminal and run the command AWS configure. If the CLI is not installed on your computer, you need to install it first. I have added a helpful link in the video description on how to install the CLI. Please refer to that. If you are using a Mac, open your terminal. On Windows, you can use command prompt or a PowerShell. I'm using PowerShell here. And when I run AWS configure, it prompts me to enter the AWS access key. I'll paste the key that was generated and then press enter. Next, it will ask for the secret access key. Paste that as well. For the region, I will go for North Virginia region, which region code as US East 1. As the intended region is already selected, press enter without providing any input. Now choose the default output format. Options include JSON, table, or text. I prefer JSON, so I'll press enter as it is already selected. However, please understand that the access keys and secret access keys are not supposed to be shared or displayed anywhere as they provide access to your cloud resources. Exposing them can lead to unauthorized usage, data breaches, and potential security threats. So always store them securely using environment variables, secrets manager, or configuration files with restricted access. In this case, I am displaying them strictly for demonstration purpose to show you how to use them during this hands-on setup. And I will immediately delete them after the session. So I have successfully connected to my AWS account using the IAM Users access. Now I can launch an EC2 instance using the CLI, just like we did in the AWS Management Console. For that, run the command as displayed, and AWS EC2 run instances is the base command we use to launch a new EC2 instance. Image ID specifies the Amazon machine image we want to use it. And this particular AMI is for Amazon Linux in the North Virginia region. Now count to 1 tells AWS how many instances we want to launch. In this case, just 1. Instance type, T2 micro. We are selecting a free tier eligible instance type called T2 micro, which is good for basic workloads. And security groups default, this assigns a default security group to the instance, and tag specifications to give a name to the EC2 instance. In this case, CLI instance. Now click enter. And you will see the instance is being launched successfully. The entire output is displayed in JSON format. And you can see the instance ID, the instance type, the launch time, the availability zone, and many more details. And you'll also see the instance reflected in the console. Okay, so you can see the tag which is applied and the instance ID which ends with A964, which is the same which got launched, ends with A964. Okay. So finally, let me show you how to perform the cleanup. First, terminate any running instances. So select the instances, click on terminate instance. Next, delete the IAM user. So go back to users. You can simply select the IAM user and click on delete. However, if you just want to remove the user's access without deleting the IAM user, navigate to the IAM user, go to security credentials, and you can disable the console access as shown before, or deactivate or delete the access keys. So you can do the same for other security credentials as well. In this case, I want to delete the IAM user. So scroll to the top, click delete at the top right corner, provide the IAM user name, and click delete user. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.